Today we are going to talk about the Shapley-Shubik power index. So first of all, these two gentlemen, Shapley and Shubik. Shapley was a distinguished American mathematician and Nobel Prize winning economist. He was a professor emeritus at UCLA, affiliated with the departments of mathematics and economics. Martin Shubik was an American economist who was professor emeritus of mathematical institutional economics at Yale. They both died in the last few years, so their findings are relatively recent. So let's start with some information about the Shapley-Shubik power index. So in this process, we are interested in sequential coalitions, which means that they are formed in order instead of the coalitions being formed all at once. Players join the coalition and cast their votes in an orderly sequence. So there is a first player, then there's a second player, a third player, etc. A pivotal player is a player that contributes the votes that turn what was a losing coalition into a winning coalition. So, in the Shapley-Shubik power index, a player's power is obtained by counting the number of times it is a pivotal player and dividing by the total number of pivotal players. So basically, same thing as Bonshoff, except now we're using pivotal players instead of critical players, and sequential coalitions instead of ordinary coalitions. So here are the steps. First, you make a list of all sequential coalitions. You determine the pivotal player in each, count the number of times each player is a pivotal player, divide that by, so for example, you divide the number of times P1 is pivotal by the number of sequential coalitions, and this will give you the power of P1 according to the Shapley-Shubik power index. So let me show you some notation. So let's look at this weighted voting system. Our quota is 4. We have 3 players with 3, 2, and 1 votes respectively. So think of a sequential coalition as a permutation, because that's really what it is. So you have 3 players. You need to write all of the possible sequences for these 3 players. So for example, you could have player 1 go first, then player 2, then player 3. And we are going to use the angled brackets for sequential coalitions. You could have player 1, then player 3, then player 2. That is a different order. You could have player 2, player 1, player 3. You could have player 2, player 3, player 1. You could have 3, 1, 2. And lastly, 3, 2, 1. Those are all of the possible sequential coalitions for 3 players. So now we are going to write down the votes going in this order. So if we go player 1, 2, 3, we have 3 votes for player 1, 2 votes for player 2, 1 vote for player 3. So for the second winning coalition, I have 3 votes for player 1, 1 for player 3, 2 for player 2. 2, 3, 1. 2, 1, 3. 1, 3, 2. And 1, 2, 3. So that's the number of votes following this order. So now the question is, who is the pivotal player? So if we start with just player 1 who has 3 votes, is that enough to win? No. Well, if we add in player 2, now we have 5 votes, and that is enough to win. So player 2 is the person who took us from a losing coalition to a winning coalition, so player 2 is our pivotal player. So we're going to do the same type of thing for all of these. Is 3 votes enough to win? No. If we add in another vote, now we have 4 votes. Is that enough to win? Yes. So player 3 is our pivotal player. Is 2 votes enough to win? No. If we add in 3 votes, now we have 5 votes. That is enough to win. So player 1 is our pivotal player. Is 2 votes enough to win? No. If we add in another vote, now we have 3 votes. Is that enough to win? No. If we add in 3 more votes, now we have 6 votes. That is enough to win. So player 1 is our pivotal player. Is 1 vote enough to win? No. Is 3 votes, adding in 3 votes to getting to 4 votes, enough to win? Yes. So player 1 is our pivotal player. And lastly, is 1 vote enough to win? No. So let's add in 2 more votes. Is that enough to win? That's 3 total. No. Add in 3 more votes, we're up to 6. That is good enough. So player 1 is our pivotal player. So how many times is player 1 pivotal? 4. Player 2 is pivotal once. Player 3 is pivotal once. We had 6 total sequential coalitions. So we are going to use the Greek letter sigma for the Shapley-Shubik power index. So the power of player 1 is 4/6 or 2/3. For player 2 is 1/6, and player 3 is 1/6. So this is our Shapley-Shubik power distribution. Now, we did this same example when we did Bonshoff in the previous video. So Bonshoff, the power distribution was 3/5, 1/5, 1/5. So you can see that both of these agree that player 1 has the most power. They agree that players 2 and 3 have an equal amount of power, but the fractions are not identical. Okay, so you will get similar results with the 2 different power indices, but they will not necessarily be identical. Now, you might be asking yourself, how do I know how many sequential coalitions there are? Well, let's refresh our memories about the multiplication rule. So, the multiplication rule, or the fundamental counting principle, says if there are m ways to do x and n ways to do y, then x and y together can be done m times n different ways. So, if an ice cream shop offers 3 different choices of cones and 5 different flavors of ice cream, how many different possible ice cream cones are there? Well, you have 3 cones times 5 flavors. That means there are 15 different ice cream cones. Well, a bigger ice cream shop has some more options. They have 6 choices of cones, 32 flavors of ice cream, and 9 different toppings. If you are going to get a cone, a single scoop of ice cream, and a topping, how many orders are possible? Well, there are 1,728 different ice cream cones with toppings. So you might be asking, okay, what does this have to do with sequential coalitions? Well, how do we count the number of sequential coalitions with 5 players? Well, first we have 5 options for the first player. Once that player is chosen, we have 4 options for the second player, 3 options for the third player, 2 options for the fourth player, and 1 option for the fifth player, which gives us 120 different sequential coalitions with 5 players. What about with 4 players? Well, you start off with 4 options for the first player, 3 options for the second, 2 options for the third, and 1 option for the fourth. And you might remember that this is 4 factorial. This previous one is 5 factorial, where you start with a number and you multiply by every number less than that number all the way down to 1. This would be 24. So, to find out how many sequential coalitions there are, you just do n factorial. And that is it for the Shapley-Shubik power index.